Dear students, how are you? Hopefully you all are doing well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today we are going to discuss about the differentiation. Especially we are talking with chapter 9D, where we will discuss some inverse trigonometric functions differentiation. We will here discuss also how to convert the degree into radian then differentiate. And this lecture will be very beneficial if you write when you will watching the video. Hopefully this lecture will be very beneficial. Let's have a look at today's class. Thank you. Dear students, according to our lesson plan, today we are going to discuss about chapter 9D. Here we will discuss about some inverse trigonometric function of the derivative. So let's have a look some first rules for today's class. Here we will learn some important formulae. Our first formula is dx of sine inverse x. Here we have already known that sine x, if we have this derivative of the sine x, then we will get cos x. But what about the inverse function of the x? That's our today's plan. So ddx of sine inverse x is nothing but the 1 by root over 1 minus x square. And what about cos inverse x? ddx of cos inverse x should have been (1 by root over 1 minus x square). All are same, but we'll use a subtraction in here. Clear? So now the students will go for differentiation of tan inverse x. Will be what? ddx of tan inverse x is very common thing, that is 1 by 1 plus x square is the rules for ddx of tan inverse x. And now we'll discuss about ddx of cot inverse x. What can be it? Guess it. Exactly. Thank you very much. Everything is okay. We'll just write a extra minus on it. Then we'll get ddx of cot inverse x is nothing but minus 1 divided by 1 plus x square. Okay. Here two trigonometric ratio is there. Which two? First ddx of cosec and sec. So we'll write first what? Sec. So what should be the ddx of sec inverse x? Exactly 1 by x into root over x square minus 1. 1 by x into root over x square minus 1 is the formula for ddx of sec inverse x, and the last one should be ddx of cosec inverse x, and I believe that you have already can understand what should be the formula of it. Exactly, only the minus will come extra on it. So the formula of the cosec inverse is minus 1 divided by x into root over x square minus 1 is the formula for ddx of cosec inverse x. So my dear students, these all the formulas are very important for this chapter, and I believe if you have the sound knowledge and deep thinking about these formulas, then we can solve these chapters, all the maths very clearly. Okay, let's have a look our mathematical part of today's lecture. So dear students, our today's first mathematical math is differentiation of sine root over x. So how we can solve these types of math? We can solve these types of math very clearly. What we have to assume this part, I mean the root over x, as x. Okay, so if we assume root over x as x, then what is the differentiation of sine x? So the ddx of sine x is nothing but the cos x. But since this root x was considered at x, that's why we have to differentiate this assumption part again. And we have already known that differentiation of root over x is nothing but the exactly 1 by 2 root over x. 1 by 2 root over x. Then we can write cos of root over x divided by 2 into root over x. And here one thing we have to understand, that if you have any confusion of root over x equals to 1 by 2 root x, then I can prove it right now here. So d dx of root over x, that's the question. And here d dx of x to the power half, and we have already known the formula of d dx of x power n is equals to n into x power n minus 1. We'll just use that formula in here. Half into x to the power half minus 1, it should be half into x to the power minus half, half into 1 by root over, actually half, so 1 by 2 into 1 by root over x, that means 1 by 2 root over x. So I think you should remember the formula of d dx of root over x equals to 1 by 2 root x. Otherwise you have to write this all the steps to find root over x value. Okay, so that's our first question, and that's our first answer of the first derivative part. Let's have a look our next question. So now, dear students, our next mathematical problem is d dx of sine x degree. We have to understand one thing at the very beginning of our derivative part, when I was lectured in your Zoom class, that I was expressed that never will go for the degree part of the differentiation. You have to convert the degree into radian first. So what was the conversion hour? 1 degree was pi by 180 radian, and for x degree should be pi x by 180 radian. So we'll just use it here, and then we'll differentiate. So we'll write d dx of sine pi x by 180. Then if we derivative this part, then what we can write? We have a formula, that is sine ax. If we differentiate sine ax, we got what? A into cos x. Have you remembered the formula? So why I am going for the a here? Because a was the constant part in here, and here our a, it will be actually like this. I want to rearrange the line right now. Sine pi by 180 into x, where pi by 180 will be working like the a. Now we will just use this formula in here. So if we use, then we will get a into cos x. So here this part was a, so a into cos ax. So our answer should be like that, pi by 180 into cos pi x by 180. So that's the answer of this math. Clear? So now we'll go for our next mathematical problem. So dear students, how we can solve this? First of all we have to go this line like this way first. D dx of sine ln x square whole square. Why? Because we know that sine squared x can be written as sine x whole square. Sine squared x can be written as sine x whole square. So here we have to assume that this part is equals to x. So sine x whole square, if we derivative this part, then what it can be happen? D dx of sine x whole square. That means we have to think this sine x. So here this part is not, we'll think at is x, rather we'll think the whole part is x. So here it should be x to the power n formula. So what will be the x to the power n formula? We will think all of the parties as x, all of it is x. So x square, if we derivative x square, then we will get 2x. So we can write 2x, that is 2 into sine ln x square. Okay, but here the question is, this was not the exactly x. Why? This was something, so we have to derivative that part right now. So dx of sine, then ln into that part, dx of sine into ln x square, sine ln x square will be the part. Okay, because that was, we are thinking that that was our x. Here this part will be remain as usual, same, ln x square. So now we will think actually our this part, that is ln x square, as x. So sine x, if we do derivative sine x, then what we will get? Exactly cos x. So it can be written as that this part is cos x. So cos ln x square. So that part was our genuine x? No, that was our ddx of ln into x square, because it was our assumption x. Okay, now 2 sin a cos b, 2 sin a cos b or 2 sin a cos a can be written as that sin 2a, this part 2 sin a cos a, so sin 2a. And here we can write that here actually this x square will be thinking as x. So what's the formula for ddx of ln x? Exactly, ddx of ln x can be written as 1 by x. So 1 by x, that is x square. Since x square was not our original x, that's why we have to go for again that ddx of what? X square. Now what we will get finally? Sine 2 theta, that is ln x square, 1 by x square, 2x, x gone, then 2 by x sine 2 into ln x square. That's the answer of this math. Or you can write another line in here, that is actually 2 by x. This 2 will become this word, because we know that log and log, if in there, then the power can become in front. So it can be sine 4 ln x. That can be the answer. So dear students, this is how we can solve these types of math. But when you will be able to solve these types of math by one line, on that time I can say yes, you have the idea about the derivative. Okay, let's have a look and let's try. Can you solve this math by one line? Let's try. Okay, here we will first think that here was sine square something, that's why we can say that must be sine x whole square. So we can write on the time 2 sine ln x square. Okay, because we are thinking all of that part. Now sine, this we will differentiate. So what will be that sine into x? That must be cos into x. And here now sine part has been gone. Now ln into x square, that must be 1 by x square, and now x square should be 2x. So that's the answer of this math. So if we just cutting down all of that, then this part should be sine 2x, and here ln will become, so 2 into 2 into ln x. So we can say here it should be sine 4 ln x into here, if we cut x is gone, so it should be 2 by x. That's our answer. Very easy, isn't it? Just you have to think about the part by part and going for the same line. If you do that in your by practicing, then you can think that yes, you are able to write or you can solve all of the differential math within a very short time. Okay, now let's have a look our next question. So that's our last math for this lecture. Here we have observed that there is 2 degree related problem, and we have already told you that when the degree will become, we have to convert it in radian part, isn't it? Okay, if we make it in radian part, what can be written as dx of x pi by 180 sine x pi by 180. Now since these two are the x related 2 parts, so we'll think that this is our u and that is our v. What's the formula for ddx of uv? You know? Very good. U ddx of v plus v ddx of u, isn't it? That's our formula. So we'll just use that formula in our third line. So we can write here u ddx of v, then plus v ddx of u. Okay, so u ddx of v plus v ddx of u. We'll just use the formula in here. Okay, now we'll differentiate. Okay, so x pi by 180. Here I have already told you ddx of sine x can be a into cos x. So what is the a of here? A is x by 180. So we'll write here that a, that should be the pi and that should be the x. Okay, so a into cos ax, that is pi by 180 into x. So sin x can be sin ax is the definition, derivative of sin ax is a into cos ax. Okay, then plus this part will remain same, sin x pi by 180, but here we have already known that dx of, say for example, ax, since a is constant, then a will become at first, so a into ddx of x, and we have already known ddx of x is 1, so it should be a. So here a means that pi by 180, this part pi by 180, so it should be like that, pi by 180 into ddx of x, and you all know this is nothing but the 1. So what we have found finally? We have found pi square 180 into 180, you may write 180 square, then x, then cos pi x by 180, pi by 180, sin x pi by 180. You can take common pi by 180 in here, so taking pi by 180 as common, then we will get pi x by 180 cos pi x by 180 plus sin x pi by 180. So here we have found our first answer. It can be actually the first bracket, no need to going for this third bracket or second bracket. It will be very good if we just pi by 180 will be taking common, then pi x by 180 into this. So that's our required answer. Dear students, again I wanted to say you this differentiation math is very important for your examination. If you have the sound knowledge on the mathematics part, especially in this differentiation part, then you will be able to solve these types of math in a single line. When you will go for that, then you will think, yes, you have a sound knowledge on differentiation, then you can solve the integration part also very easily. So that's all for our today's lecture. Hopefully this lecture is very beneficial for you. If you have any confusion in any problem, anytime you can call me, anytime we are all here for help you. That's all. Thank you very much.